Hello friends, how are you all? I hope you all are in good health. I am back with the part 2 of the video Ripple Control Receiver. It is a very useful and informative video for all the beginners to learn. Please like, subscribe and share to my channel for more tech related informative topics. And don't forget to press the bell icon for new video notifications. Now let's get into the video. So we are discussing about generation and measurement of ripple. There are two technologies currently in use for generating the injected signals: motor generator set, static frequency converter. Motor generator set. An electric motor is used to spin a generator which supplies the desired injection frequency. A contactor is used to apply the injection signals to the network via turning coils and an isolation transformer as appropriate. Static frequency converter. Electronics are used to generate the injection signals which are again applied to the network via an isolation transformer and tuning coils, where these injected signals are applied. In urban areas, the signal is generally applied at 11 kV, while in more rural areas may be at 22 kV, 33 kV or 66 kV. What frequency range and amplitude is used? Frequency varies from 100 Hz to 1600 Hz, having bandwidth 5 Hz to 40 Hz with maximum amplitude of 0.3% to 4% of operating voltage. There are various methods of encoding the signal which is superimposed onto the normal voltage waveforms: decabit, semagier, pulsidius, recontic B. Decabit. The decabit system comprises of a start plus pulse 10 coded pulses. Each decabit injection comprises of 5 asserted pulses and 5 non-asserted pulses. A receiving relay turns on if it receives the 5 asserted pulses corresponding to its programmed channel. The relay turns off if it receives the inverse of the on code. Each injection lasts 600 minutes. The semagier, Placidia and reconated B differ in maximum number of pulses in each telegram, the pulse width and absolute pulse support. Impact of ripple. Under normal operating conditions, there is little impact on equipment due to ripple signal attenuation, ripple signal amplification. Ripple signal attenuation. Cause: if signal losses in the network are too high or if the injection level at the signal source is too low, the magnitude of the signal when it reaches the receiving relay may not be sufficient for the relay to operate. Impact. The main impact of receiving relays not operating is that the load which is controlled by the relay will not turn on or off as appropriate. This is a particular problem for relays which control off-peak hot water systems. If the receiving relay does not turn on the water heater as appropriate, The water will not heat and the customer will be left with the inconvenience of cold water. Conversely, if loads that are meant to be turned off stay on, it can adversely affect network loading levels and defeats the purpose of the injection control system. Ripple signal amplification causes. The main mechanism for signal amplification is network resources. Under certain conditions, the impedance of the network is such that there is resonance at the approximate frequency of the injected signal. Impact. High ripple signals include flickering of dim lights or touch lamp, audible noise through speakers as well as devices with laminated motors such as ceiling fan. Also can cause racing clock phenomena due to multiple zero crossing on voltage waveforms. Resolution. Mitigation of ripple signals which are at inappropriate levels is not straightforward as signal levels are not homogeneous across networks and will change with network development and addition of loss of load. For signal levels which are too low, the injection level is generally increased at the source. Two main methods are used for mitigation of signal levels which are too high. These are changes to the network in order to change the network resonate frequency and filters. So guys, that's it. That's the end of my today's video. Thank you for watching.